Good morning, you guys. All you brave souls who got up at 9 o'clock, I have to say. Anyway, so I'm going to give a talk today about RFID. I'm just really curious, how many people here in the room actually know somewhat a little bit about RFID? If you think you know something about it, if you could raise your hand. Okay, well, that's a fair proportion of the crowd. So basically what I'm going to talk about today is I'm going to talk about a little bit of work that I did at my university. It's on the security and privacy of this technology, radio frequency identification. And I'm not going to talk about the whole field at large, but I'm going to talk about my little corner of the universe that I've been working on in the last few months. So, but I'm going to start off first with what is RFID. So RFID, it's kind of like these, these little theft control tags. Like if you go into a department store, oftentimes you'll have this little tag attached to your clothing. You take it to the checkout. They forget to deactivate it. You walk out the door. It goes beep, beep, beep. Security guard runs after you. RFID is actually a whole lot like that. But essentially what it is instead of having one bit of storage on these little tags that are powered by their reading devices, they actually store a bit more. So just like with Moore's Law has helped computers to get better. Moore's Law is also helping these little theft control tags to get better. So slowly but surely they're getting more than one bit of storage. They're starting to get, perhaps maybe 1K bits, 2K bits. If you have what are called contactless smart cards, I mean, you can certainly, there's new ones coming out that are just in quite a few kilobytes. And the point is, as these tags get more advanced, they're actually starting to become more and more computers. A lot of people, besides calling these things radio barcodes, also consider RFID tags to be a kind of computer of the future. So, but what's actually more interesting about RFID is some of the uses that it's used for. Part of what it's used for is things like eliminating counterfeits. There were some rumors going around for a while about the European Central Bank implanting RFID tags in money. They were just rumors. People were like, nuking their bills and stuff to see if these tags were really in there. But it subsided after a while. I've heard actually since then that there were rumors about Swedish kroners getting these things, just raising the discussion again. There's also more IDs. Of course, the passports. And this is one of the really big controversies that's been popping up lately. They want to use these things just for their storage abilities, even more than for the fact you can read them from a distance, but just so you can store biometric information, stuff like fingerprints, picture of your face, because that's actually too much information to put in those little, what they call machine readable zones, those little barcodes they have when you swipe the passport. So they're also using them for things like drugs. I mean, you wouldn't want people, copying your Prozac or your Viagra. So, I mean, their idea is you have these containers, maybe like 10,000 of these pills. You put a tag on it, and basically as it goes through the supply chain, they want to assure that probably these very expensive bunches of drugs that you're actually getting what you're paying for. Supply chain management is another really big one. A lot of the really big players are using it. Walmart did a mandate probably about like 2 years ago, I think, at this point. And that was really one of the big motivators, one of the things that really spurred RFID into being used. As soon as Walmart said, we're going to start using these things, because RFID tags on our pallets and our containers, because we think we can optimize our supply chain, increase our return on investment. All the suppliers, like the top 200 and then the top 300, all of a sudden we're confronted to use this new technology or lose one of their biggest clients. So, and of course all their competitors noticed and took suit, and I don't know. I'm not much of a gambler, but I wouldn't gamble here. But I would think if you play the stock market, that a lot of the stocks for these RFID companies are probably going to be doing well over the next few years. Automatic payment is another one. For example, going back to some of these supermarkets, there's the Metro Group in Germany has something called the Future Store in Rheinberg, Germany, and their vision is just that you have this, just this shopping cart. And you basically just, walk through the store, grab all your groceries, toss it in there. You can basically walk out a portal, In fact, I think IBM made a video about this one time. Or you could just grab all the stuff in your jacket, walk out, security guard is like, gives you a bill, thank you, Mr. Rieback. And that's really their vision about the future of computing. That's their vision about what can we do with this technology. How can we make the lives of people easier? They have really good intentions. This is all about how can we make lives simpler. There's also other automatic payment options. There's things like PayPass and ExxonMobil SpeedPass. Basically, you can get these little transponders on your keychain. I mean, if you want to buy something from a vending machine, who needs change anymore? Change is passé. You just take your little keychain, wave it. It's all taken care of. Same thing with when you're paying tolls. Who wants to wait in lines anymore? You just drive right through. It sends the bill to the right place, and that's all you need. Also, Philips, like in the Netherlands, where I'm living these days, they also are trying to get in on the act. In fact, they're one of the largest manufacturers right now of RFID tags, but they're also working on something called near-field communications. And it's the exact same idea. It's like if you have a cell phone, it uses something that's a whole lot like RFID protocols, and you use it again for contactless payment. So that way you don't even need to carry an extra keychain, a little keychain to pay for your things, but all you have to do is take your cell phone, which is something that you're going to have with you anyway, and you can use that for your payment. So this is all part of their really grand vision about what this technology is good for. Object tracking. You can use this for tracking things like library books. Believe it or not, in the Vatican Library in Rome, I think usually they're not all that savvy to change a new technology, but they're actually one of the first adopters of these RFID tags for automating their libraries. Things like tagging animals, like livestock, things like dogs and cats. I mean, people are starting to put chips into them. Things like luggage. I mean, we all flew into Las Vegas McCarran Airport, probably. I mean, they're one of the places, one of the first airports that's doing trials with this RFID technology for the baggage to make sure it doesn't get lost. And so we're tagging all these objects. We're tagging the dogs and the cats. We're tagging the livestock. What's the logical next direction for all of this? Of course, you're going to start tagging people. So there's this company called Applied Digital, and they make these things called Verichips. And essentially what they are, they're tags that are about the size of a grain of rice. They just have a little antenna, one a little core, and you just implant them. And there's actually a place called the Baja Beach Club. It's actually about a 20-minute drive from my apartment. This place is located in Rotterdam. There's actually another one also in Barcelona. And they actually use these RFID tags as part of their sort of like their VIP network. So what they do is you basically go into their bar and you sign up. It's really painless. You just go sign a few forms, liability, stuff like that. Then you just get this little injection. Shouldn't bother you too much. You just get your doctor to do it. You're cool. You're not too worried about it. And afterwards, you're just, you're feeling just really good. You've got this, you've got this chip. I mean, now you're just ready to get totally wasted and know that you can still actually pay for what you're drinking. So this is all just, this is good stuff. And then once you actually have this tag injected, as you can actually see in this picture over here, is you become a number. You become basically a part of their system. So, I mean, here you can see that they're scanning the woman. You can see on this handheld reader that they're using that there's a series of numbers coming up. And then if you look at the next one, basically they have the screen, and you can see now exactly the same number at the upper right-hand corner of their screen. And essentially they use that to basically as the account number, the debit account number for paying for your drinks. So, it sounds like a really good system. But, but what about security with all of this? So, one time a reporter decided to go to the horse's mouth and ask about all of this. And the answer was, the CEO said, Applied Digital's implantable chips do not employ cryptography as of yet, but the system is nevertheless safe because its chips can only be read by the company's proprietary scanners. So yeah, so I'm feeling safe. So there's a number of security problems with these RFID tags. Most of them have been come up by just people around in the community. Some of them are really well known. Things like unauthorized tag reading. Now, if you have one of these Verichips, I mean, all you have to do really is just have the right reading device, and anybody can get the information. It doesn't really do any access control. It doesn't really do anything special to verify, who is actually asking for the data. Another thing is eavesdropping. You can eavesdrop on the communications of between the reader and the tag, and in such a way you can actually information about, like for example, what tag is it? And in such a way, even without maybe even being in close enough proximity to the tag to be able to read the information directly, you can still get enough information to do tracking of people and things like that. Well, tracking, that was another one. Sometimes you want it, sometimes you don't. When you don't, this is a problem. Tag cloning. We were talking before about the Verichips. I mean, there was a paper that just came out a couple of months ago by a guy named Jonathan Westhughes, I believe the CTO of Harvard Medical, who has one of these chips implanted in his arm, and a few other guys. And basically, they had reverse engineered how the thing worked and cloned it. So, I mean, so much for the statement about how they could only be read by the company's proprietary readers. And finally, denial of service. I mean, if you're just using these chips in your arms for things like paying for your drinks, then it probably doesn't matter if occasionally. But what happens if they start getting the idea of putting your health information, your medical information on these tags? So let's say, I'm outside, I'm crossing the street. Let's say I, slip and I fall, I'm in a coma, and the ambulance comes and picks me up. Now let's say that I'm allergic to penicillin. This is information that they would need to know, and they figure, why do you have to wear one of these little bracelets? You can just put this information in here. Everybody can just read the chip, and they know. But the point is, if you do denial of service on these kinds of tags, you could then not get the information at the critical time. And when you're talking about health information, people's lives could be at stake. But these are just some of the RFID security problems. But actually what I'm going to talk about, I guess at some point I decided that RFID didn't have enough problems already, so I was going to go and try and investigate a new class of problems. And basically, I did some work on RFID malware. So malware is more or less what you would expect it to be. It's not so much high-level misuse of tags. It's not things just like copying valid data, transplanting it to another tag, and just leaving it. It's more that you actually take data that is in some way invalid. You take data that's in some way corrupted or unexpected, or it contains some kind of information that when it parsed, it causes things in the back end to break. It's malware. It's just like the traditional computer attacks y'all are used to seeing on the internet. And basically the only thing I really did with this work was show that you can take traditional malware, condense it down to about the size of an RFID tag, and use it as one more vector that hackers can use for attacking systems. So there's three main kinds of RFID malware that I was investigating. There's RFID exploits. That's just a simple kind of like one-shot deal. You just do the attack once, and it does its damage. There's RFID worms, and there's also RFID viruses. And I'm going to spend some time actually explaining what the difference is between these three categories. So, but first, you're going to ask, okay, if we're talking about how to infect RFID middleware, first question is, what is RFID middleware? What is it that makes it susceptible to these kinds of attacks? And the answer is quite pretty much what you would expect. What we have here is a picture taken from Sun Microsystems, a bit of the architecture of their RFID system. And I'm just going to point out a few of the really salient points about it that make it RFID malware, or sorry, RFID middleware. So it has RFID readers and tags, middleware without having these readers and tags. You're probably going to have a database. Because if you have all of these, if you have this Internet of Things, basically, and you're just reading probably, thousands or millions of these tags, you need something to do. You need to do something with it. You're going to have the usual data management problems. So, I mean, what do you do with it? You just stick it all in a database. You do the usual queries on it. You prune out the data that's irrelevant. It's the same old data management problem we've been having. So middleware has these databases. It also oftentimes has a network connection. There's an organization called EPC Global, and they're beyond this grand vision of making this Internet of Things. And they want to use these RFID tags called the electronic product code. They're 96-bit tags, and they're kind of like little license plates. That's kind of how they envision them. And they're a bit like traditional barcodes, but they've slightly extended it to make them unique for individual products. And the point is that if you have an item, for example, on the supply chain, and it travels from point A to point B, if it gets lost completely, they recover it at a point C, and then what they want is that you can go on the internet, figure out where exactly did this item come from, and then you can just send it back to its destination. So this information is basically worldwide accessible. You know, it's global. Everybody's sharing all of this, and you have this unique ID that can help you get things back underway. And that's all well and good, but just remembering that the system then requires network connectivity. And of course, once you introduce a network into a system, you're introducing all of the usual cans of worms that we're used to. You're probably going to have a management interface. I mean, RFID systems oftentimes are really meant for business people. They're meant for managers. They're meant for people who don't know how to construct their own SQL queries. So they oftentimes just need a nice little point-and-click interface to help them get stuff done. They're not always going to be on site, so, I mean, oftentimes these things are going to be web-based, so they can sit in their offices and track what's going on in the warehouse. That's all well and good, but when you have a web interface, you're introducing things like web protocols, and this is yet another venue of like new ways that you can introduce attacks. You're going to have data filtering and correlation software. I mean, it can be incredibly complex because it's not. For example, if you get multiple readings of the same item, I mean, sometimes you might want to filter them out just because it's extraneous noise. Even if you have several readers, sometimes several readers are kind of positioned in different places, and you just have to have all the logic to really be able to filter out the wheat from the chaff. But of course, all of this is leading to yet larger programs, and it's sort of leading to a bit of the bloatware that we're used to, just in a new domain. And finally, glue code. For example, if you have your RFID readers, oftentimes, let's say you're going to have something like, you know, an API that you're going to use to tie it together with the rest of the system. Like, for example, with some of our middleware, we have this little Philips iCode My for Pagoda reader, and it comes with a C API. And, you know, that's great. And I can just use some, you know, some database libraries and stuff to just tie it into, you know, everything it needs to be connected to. But the problem is, when you start using things like C APIs, you start introducing possibilities for things like buffer overflows, and a lot of those traditional attacks that we're used to. So basically what we did is we constructed a malware test, RFID middleware platform, actually, that we just wanted to be representative of a typical RFID middleware system. We actually wanted to do this for a couple of reasons. First, because it was modular. I mean, basically the way that we did it is we had this Philips reader, and we connected it basically to 4 different databases. We had MySQL, and Postgres, and Oracle, and SQL Server. And essentially it just actually allowed us to try different kinds of exploits with different databases, because we actually found out that some databases were actually, actually better protected against some of these attacks than others. And it really led to a really convenient testing platform for us. It was also the same with the web interfaces. We built a couple different kinds of web interfaces. I mean, we used Perl and PHP. And once again, I mean, certain implementations in certain languages made things basically safer than others. But it was fun to play with it. And another reason why we wanted to use a generic malware test platform is essentially to kind of clear ourselves. Because basically, what we didn't want to do is release a cookbook on this is a real deployed middleware system, and this is how you attack it. Here's some code samples. We didn't want to provide that. We just wanted to show the concept. The only really point we were trying to make is, look, RFID tags are extending your network perimeter further than you're used to. And for the rest, I mean, I figured, once I talked to people at, maybe not even at Black Hat, but once I talked to the people at DEF CON, there's going to be enough people that are going to try doing their own implementations anyway. So this is the point where we wanted to stop. So, and also for legal liability, because we already had some RFID companies that were a bit mad at us. But I'll get to that later. So getting back to the exploits, there were a couple different kinds of exploits that we were playing around with. One of which was buffer overflows. Now you're going to ask, how in the world do you put a buffer overflow on an RFID tag? If you think it has, 1K worth of bits, that's about 128 characters. How do you put a buffer overflow into 128 characters? And the answer is pretty simple. If the middleware developers are using small buffers, then it's easy to overflow them. It all depends on what kind of data they're expecting. Now, if you have, for example, a system that expects a couple different data values like apples, oranges, and peaches, if that's only like 6 characters, and they only allocate a buffer 6 characters long, the point is you can still go ahead and overflow it. Another example is, because everything is standardized, this makes it really easy. If they assume that you're going to be getting, using 1K tags in your system, for example, using one of the usual ISO standards, and you happen to, have your own tag available, that's 2K worth of bits, then it's more than enough space to still be able to overflow the stack, push the return address into the right place, and actually insert your own custom code. And we actually did this. I also want to mention, by the way, there's code samples of all of this available online. If you go to www.rfidvirus.org, you can basically find samples of everything I'm talking about today. And you can go ahead and play with it yourself. And this stuff, this stuff all works as advertised. So we've also got an example of a buffer overflow up there. So another thing that we were sort of hypothesizing about is write multiple blocks. So basically, if you're using a tag that's sort of bigger than you expected, essentially, if it asks how many blocks are available, usually the tag will tell you. And then if you use that then to keep iteratively reading the new data blocks, then you can go ahead and basically get more data out than you would expect. But the point is, if once again, if on the application level, if the developers are assuming you're just going to have a tag, that's only this big, and they sort of assume then that, okay, well, I know there's, always going to be, 16 data blocks, so I'm just going to allocate enough size for that. But they still have the command available that does masking. You could still, in such a way, overflow some larger application buffers. And another thing that would actually make it even easier is if you have an RFID tag emulator. Now, you guys are probably going to ask, RFID tag emulator, do those things exist? Where do you get one? And the point is actually we built one, and I'm going to be giving a talk about it at DEF CON. So essentially, once you actually have a computer, and it can talk RFID protocols, it can speak RFID language, but it doesn't have any of the limitations, none of the resource limitations, none of the power limitations of RFID tags, then you can just completely blow all the constraints out of the water. And at this point, it just makes the attack so much easier. So, and these are things that system developers need to consider. There's another kind of attack. This is actually an even easier one to be able to implement. Is code insertion, and there's a couple different kinds of code that you can insert. A general, of course, giveaway for code insertion attacks, just like when you're using web pages, like if you're building, a web banking or a web store application. It's common knowledge. Filter out special characters. I mean, I know everybody in this room knows that. But the question is, if some guy from, random state university who just recently graduated and, doesn't have much of an education in security, if he knows that, and sometimes it's as simple as just calling a library, to filter these things out, but sometimes people don't. And the problem is if you don't filter these things out, then you can do a lot of the really traditional attacks that we're used to. One of which, and you can actually target some attacks against, for example, that web interface that I was telling you about before. You can do things like client-side scripting attacks. Like, for example, one attack that we demonstrated is what you can actually do, put on an RFID tag, basically script tags, and then you can basically do a redirect to URL with a file with the WMF bug. And then you basically just redirect them. It compromises the browser. And as such, as a hacker, you have an entry point now into the management interface on their system. But it's still, you're attacking the client, so you've only really compromised that one client. Of course, if client has trust, you can do a lot more. But you can also even go directly after the server and just do some server-side scripting. You can do things like put in server-side includes. And then when your manager, who's here with his management interface, decides to go ahead and click and see how his little package is doing, then it's just going to run. It can run arbitrary code basically on the server. And once again, this stuff all has basically trust. This can directly access the database usually. And the whole point of the RFID system is it's all about the data that you're storing. And once you have access to the data, you can basically just wipe out the entire worth of this RFID system. So another kind of attack it's a kind of code injection that we were focusing on is SQL injection, because this is actually even one of the easiest ones to be able to pull off in a small number of bits. And you can use it for a lot of different things. One thing is we actually used a SQL injection to be able to steal data from an RFID middleware database. So what you do is you just insert a select query in there, and you basically write that data to a data location that on the application layer eventually gets written back out to tags again. And essentially, it requires a little bit of insider knowledge to pull off this one about how the software is constructed. But essentially, in such a way, you can just perform your arbitrary query, get the data, have it written back to a tag. You don't even have to be there. The package just goes on its way, and you've got whatever it is you're trying to get after. Another one that probably has, slightly less, requires less creativity is just, modifying the DB. All you have to do is like, semicolon, drop table, and yeah, that's annoying. Denial of service. So my absolute favorite one, and we were using this one with SQL Server, is you can basically turn off a SQL Server instance by doing semicolon shutdown. And yeah, it only requires just a really tiny number of bits, fits more than adequately on an EPC tag. It's it's not fatal, so you turn off their SQL Server. But remember, if this is on a package and it keeps going from reader to reader to reader to reader, you see how it can get kind of annoying. And of course, system commands. Going back to Microsoft SQL Server, I really do love Microsoft, but they built in this feature into SQL Server that allows database admins to be able to do system commands from within their database. So they don't even have to leave the database. That's just incredibly handy. But it's also incredibly handy, of course, for attackers. You guys know this stuff. But this just makes it great for using RFID malware to infect these middleware systems. So, okay, so these are just sort of like the basic building blocks. These are the attacks. And the question is, how can you actually make them, for example, do more interesting things like self-replication? So now I'm going to talk about an RFID worm. So you're going to ask, what is an RFID worm? I'm basically saying that, well, actually, first I'm going to say that a worm is something that replicates using a network connection. It's sort of like what you would think about having a worm on the internet. Usually just does some port scanning and then basically goes automatically. It's sort of the same way. The RFID worm requires a network connection, and the RFID virus that I'm going to explain next can replicate without the internet connection. But now, assuming your internet connection is available, all it is, and this is really simple, it's just an RFID exploit that downloads and executes malware from a remote location. That's it. And essentially then, the entire logic and the entire intelligence of that attack, of course, is in the malware that you're downloading. So essentially, yeah, I mean, and then that can go and compromise the machine in its typical way. And then, but the catch is though, then you ask, how does it self-replicate? Is if you can get the malware, if the malware it downloads modifies the middleware in such a way that it causes the original attack, the original RFID exploit, to get written back to new RFID tags that show up, you've got your self-replication. Once again, I mean, it requires a bit of knowledge about how the system works. But, I mean, it's not inconceivable then that you can't implement these things if you sort of know how things work. And then it self-replicates. So at that point, then, the RFID worms can either propagate via the network or via RFID tags. And another thing is, I mean, it's a sort of a little academic exercise if you can just get it to replicate. But you can also put payloads in there. And that can then, for example, do some of the exploit things I was talking about before, like doing system commands, and you can have payloads in there, and that's what's actually going to do the real damage. So, all right, RFID viruses. I was saying before, these can replicate without requiring a network connection. And the way that I'm going to introduce it is by talking about a typical application scenario. And one of the typical ones out there is supermarkets. So let's say you have a supermarket and they have a distribution center. And essentially the way that it works is they're using these RFID tagged containers or these pellets. And essentially what happens is you have the containers that arrive. They're going to be filled with some kind of, like, let's say, fruit, coming back to the apples and peaches and pears. So what happens is that the container comes in. You essentially scan it just to see what the contents are. You unpack the container, because then perhaps you want to process the apples into applesauce or do something like that. You're probably going to wash out the container, clean it, do some things like that. You're going to fill it with something new. This might be, the jars of applesauce. And then you're probably going to write to the tag again that, this container now contains applesauce. It doesn't contain apples anymore. And then, the container, because it's reusable, it just goes on its way to the supermarket at the end of the distribution chain, and everything's happy. So basically, if you think about it, how then would a typical database look in one of these systems? And essentially the way that it would look is you're probably going to have a column in there containing a tag ID. Okay, you have these containers coming in and out, you're indexing them by their ID, that column has got to be in there. Probably what you're going to have is, sort of the known state of the world. So let's say that the last time I scanned this container, it had apples. So I'm making basically a column called old contents because essentially the last time I saw this container, these were the contents. So as you can see in this here, like for example, with tag 1, 2, 3, when the container comes in, it contains oranges. Now let's say you unpack the oranges, and then you go ahead and refill it with apples. But the point is, you still haven't relabeled the tag on the container yet. What you're going to have is something like a new contents column saying, okay, the known state of the world was oranges. I mean, some guy with a keypad is probably going to type in, okay, but it really actually now contains apples. So that's going to be in the new contents column. And essentially what's going to wind up happening is as soon as it's scanned again, the contents of new contents is going to get written into this tag. The tag is going to get scanned again, because remember the system is like continually polling. And then, of course, now apples is going to be the known state of the world. So now the new contents has been cleared, because you've already reset the data and written it to the tag. And old contents is now updated to reflect the new state of the system. So that's essentially the way that I think basically it would probably work. Just for simplicity, I'm calling this the container contents table, just make it easy. So how does the RFID virus work? Now, one of the proof of concept that we did was using a SQL injection attack. So I'm going to explain this. Now, if you take a look at it, probably on an RFID tag, the first thing that you're going to expect is the old contents. Like, let's say that you have raspberries in this crate. Right now here, I put old contents equals raspberries for legibility. Of course, that's just wasting bits, and it's completely not necessary to have there. But I really just put it there for the sake of readability to make this a little bit easier to follow. So you expect up to the semicolon, you expect that you're going to have your old contents equals raspberries. But the part that you don't expect is going to be, of course, when the semicolon starts. And essentially what you're going to do is now you're going to update the container contents table, and you're going to set the value of new contents equal to basically something that you want to be written back to the tags. I mean, you could basically replace the value, you could concatenate the value, just to be fancy. In this case, I said, let's concatenate the old value with our exploit again. Okay, that's cool. So what you wind up happening is you just have the containers, the contents of new contents. Most of the time it's probably going to be empty anyway. And you just concatenate it then with the SQL injection exploit. Okay, so that sounds like it should be good. But then you want to stop and think about what is the SQL injection exploit. So if you try to fill in the SQL injection part, you're going to realize that the SQL injection is actually everything after the semicolon. So what you're going to wind up having is the SQL injection part is equal to update container contents, set new contents equal to new contents concatenated with the SQL injection attack. But of course, this is self-referential. So, I mean, at first when we looked at this, we were like, okay, how are we going to deal with this? But we actually came up with a couple different ways. So one way that we figured out you could do self-replication fairly easily was using something like a getCurrentQuery function. I mean, a lot of databases usually have some kind of an administrator command, things like, in MySQL, get the full process list. In Oracle, you're going to have one, in fact, that's demonstrated right here. This select SQL text from vSQL. vSQL is basically just one of those magic data structures where you just pull your administrative info from. And you essentially just make sure you select out the correct currently running query by putting in something distinctive. So here we're saying basically where in the string of the SQL text there is a backtick. I'm just saying a backtick now because that's something you're probably not likely to find in the data. But as we're going to discover later that instead of using a backtick, that's actually a perfect place to put a payload. So essentially, if you take it and you put it all together, and this is actually an example of a virus that we wrote for Oracle SQL+. This actually works. All you have to do is contents equals raspberries. You do the update of the container contents table. You set the new contents column equal to, of course, the SQL injection attack, which is then basically the select SQL text from vSQL, where you're selecting out the one with the backtick. You're done. And in such a way, you've got your virus, and it does fit on a single RFID tag. And in this particular one, it was basically, I mean, we really had to, I have to admit, part of why we used the backtick was because it was one character, and we were really trying to squeeze with the bits, and this fit exactly on the RFID tags that we were using at the time. So we were also really squeezing with, the select SQL text thing, too, trying to get some of the stuff to fit. But here's an example of a slightly more complex example, just so you can see how you can also do other kind of fancier things using these viruses. So here's another example that we implemented. It's using Oracle and server-side includes. And now, because variety is the spice of life, I'm actually going to target an insert query instead of a instead of a select query. You can attack several of these things. What you do. Now, you would have apples. Instead of having old contents equals apples, now we just have apples. You close off with a backtick this time, because of course we're using an insert query. And once you close the backtick, then it goes on with the rest. And essentially what you do is then you also add something it doesn't expect. You set the value of new contents equal to, and then you can sort of see this self-replicating part again. This time we used a slightly different format of it, just to use a bit fewer bits. Select substring of SQL text from this position to this position out of that data structure. And essentially, now you're selecting out the specific one. That now instead of using a backtick, you can see that we actually have a server-side include there. And what the server-side include does is when the manager uses the management interface to take a look at to see how his data is doing, it executes the command netcat -LP1234, and it sends it to a shell. And basically, this opens up a backdoor on the system that then the attacker can get into remotely. So one other thing that's notable about it is we're also using, it's hard to see it on the slides, but it's actually, we're using two dashes to actually comment out the rest of the insert query. Because if we don't do that, it basically dies, because the rest of what was actually the valid insert query would cause the whole thing to break. So you need to basically comment it off at the end. And yeah, so, and the nice thing about this is this particular one also fits on a 1K tag. So 127 bits, or sorry, 127 characters in this example, and it still fits on basically still one of the pretty minimal, low-cost RFID tags that are out there. In fact, the particular tag, I think it costs like, I think you can get them for 50 cents on DigiKey. So we're not talking about the contactless smart cards here. So another way to do it is doing self-replication with quines. Now the problem with using these get current command queries basically is that sometimes it requires administrative permissions. And occasionally if the database administrator is being smart, he's going to make sure that things aren't running as administrator. So we're looking for basically a more generic way that we can still get this replication to work without requiring these permissions. So another way to do it is with quines. Now you're going to ask, what's a quine? A quine is basically a program that prints its own source code. Now this is stuff like out of the obfuscated C coding contest. If you take a look at a classic example in C, this is what a quine looks like. It's a little bit esoteric, but I'm just going to suffice it to say that the way that it works is it uses some kind of a variable, and it essentially uses the variable to store a copy of itself, and then it uses that to essentially both act as the program code for printing itself, and then also for the data. It's a little bit convoluted. If you want to know a bit more about this, go to Rieback by Douglas Hofstadter. It goes really into a lot of detail on self-replicating code and quines. And one example that he uses is actually from molecular biology. I mean, if you have DNA, I mean, generally it's going to contain bits that are used for replication. But sometimes, though, it also even contains bits that aren't used for replication. So the way that it works is you have things called exons, which are the bits that are expressed, and you have things called introns that are actually also self-replicated, for example, in the DNA when it's being replicated. But it also carries along these extra exons along with it, and those just kind of hang along for the ride. But you can actually change the values of those things without affecting the reproductive capabilities of, in this case, the DNA itself. And it turns out that with quines and with the self-reproducing code, you can actually do exactly the same thing with these introns. And what we discovered is that introns are also the perfect place to put a payload. So this all sounds really esoteric, and it is, but we actually implemented an example of a quine virus. This particular one uses MySQL. This is it. Basically, yes, this thing really does self-replicate. I invite all of you guys to go fire up MySQL, type this thing in. It really will come out exactly as it's typed in. But the point is, if you take a look at it, though, you can also see in the intron portion, there's a payload again. And here you can see now a server-side include that says execute command regedit. We didn't want to just discriminate against one platform. So if you're running Apache on Windows, this fully shows some of the possibilities you can do with this kind of quine virus. So this has a lot more generality, but the disadvantage, of course, is it requires a few more bits. So in this case, it required a 2K bit tag instead of a 1K bit tag. But once again, you can order those cheaply from DigiKey, and even 2K bits is still, it's still really low cost. So basically, we're just doing experiments with we'll infect different databases and kind of do a bit of a roundup of actually what works on what. And these were actually some of the conclusions that we made. Basically, the buffer overflows, I mean, they mainly target the RFID readers. In terms of the SQL injections, those worked pretty much across the board on every database platform. Things like the self-referential commands for the viruses, that actually only worked in things like Oracle, and then still with the administrative commands. But the coins worked actually on pretty much every platform that we tried. I put a little C, next to the slide here just to show that, well, C was supposed to mean contactless smart card, but if you call a 2K bit tag a contactless smart card, yeah, I mean, essentially, considering that tags are getting bigger, you have more than enough bits for this kind of stuff, actually. And then same thing with the payloads. I mean, the SQL payloads are going to work on any database, basically. The server side includes in the cross-site scripting and things you would want to insert like that, of course, requires the management interface to work. And system commands only work on certain things like a SQL Server and the management interface, and of course the reader, like when you're doing the buffer overflows. So, all right, so how do you stop RFID malware? This is stuff that you guys probably already know already. Sanitize your input, do error and bounds checking, disable unnecessary facilities, segregate users and servers. I know this is familiar. Use parameter binding. This is a specific one against SQL injection. Do code review, to try and find the bugs. Limit your permissions. Okay, and this is stuff that's completely obvious. All of us know this. But it turns out that a lot of the RFID companies didn't know this, or did know this and sort of tried to downplay the effects of what actually was happening with this malware. I mean, essentially, I did this work. I actually published this work about 4.5 months ago in Italy at a conference called IEEE PERCOM, and I wasn't expecting that there was going to be a huge reaction to the paper. I was expecting there was going to be some, but it was basically within the 24 hours after the paper was published. I think I got about like 200 emails. I mean, it was like, the reporters were calling off the hook. But the thing was, it was like the very first few reporters that talked to us got the story right. I mean, the first person who released the story was John Markov from the New York Times, and also a Dutch journalist from the Volkskrant, and they got the story right. But the point is, it's like with reporters, it's like the telephone game, because they don't necessarily all write their own stories. They just sort of, copy a little bit from another story, slap it in there, change a little bit of it, then the next reporter does the same. Eventually, you wind up with something that is absolutely, completely unlike anything you started with. So it was sort of like by day 2, you were getting these reports of like, a quote, from me, which of course I didn't say, but like, that I could bring down the entire RFID world in 24 hours with RFID viruses. I mean, they were completely blowing it out of proportion about what it could do. And just generally spreading a whole lot of misinformation about this stuff. They like the whole cat thing. I actually titled the paper, Is Your Cat Infected with a Computer Virus? And a lot of people had fun with that. You can see actually the picture on the left was from, I think Liz McIntyre from Caspian, who's one of the big anti-RFID groups. And also the one over there, they came up with a little picture for F-Secure antivirus for cats. So, but the point is, I mean, this is all like fun and everything, but then the RFID industry started getting worried. And I guess they were getting, some calls from their customers saying, hey, what's going on here? Is this actually safe? And they started putting out these press releases basically saying, these attacks will never work in the real world. This requires programming that is so inept and stupid that it is unrealistic to think that this will ever happen. And yeah, I mean, especially Kevin Ashton from Thing Magic was putting out these absolutely brilliant quotes about. I mean, not only just that, but he was actually also even trying to discredit us as a group. And one thing that he did, in one of his articles, one of his interviews, he called us the 3 Dutch kids, which is pretty funny because my boss, he's Andy Tannenbaum, if any of you guys know who Linux is. It's like he's young at heart, but and also the ironic part is the 3 of us aren't even Dutch. So. But the point is, the entire next 2 weeks, they basically were frantically putting out these press releases, trying to discredit the work. I was, it took me a few days to try and decide whether or not this was going to hurt my feelings or not. Eventually, I just said, oh, screw it, But now, I mean, it's sort of like after the backlash has died down, people have been starting to get really a more, I would say, a balanced view on this. I mean, the point is, this is just one more thing to think about. Yes, it's going to be harder if you have things like read-only tags. Then you can only use them as vectors, but you can't use them for self-replication. EPC tags, they only have 96 bits. It's true, you cannot put one of the self-replicating RFID viruses, as I designed it, onto one of those tags. But that doesn't say that one of the brilliant hackers that's out in Vegas right now isn't going to go and figure out a way to do that next week. I can't predict that. And yeah, and I mean, another thing is like tags that use crypto. They were asking about things like contactless smart cards. Will this work with contactless smart cards? And it probably depends on who's doing the attack. Because if a card, for example, has to authenticate itself to a system, you could still do an insider attack. If, for example, you have, let's say, a passport, and you're essentially, bringing it to the airport, who's to say that a disgruntled airline employee who has access to the machine that has all the keys isn't going to go and rewrite it? And then, of course, when you check the certificates and everything, it's all going to check out. So, I mean, all of these things are obstacles, but they don't make it impossible. And that's really like the take-home message that I wanted to make with this presentation, and that yes, sometimes it requires insider knowledge. Yes, sometimes there are conditions where it makes it harder. It will not work with all tags. It is not going to, furry cats are not going to bring down Las Vegas. Don't believe everything you read. But also just that this is one more thing to think about. RFID, is just another technology. It's extending the network perimeter. It's just another form of data, just like a USB stick, just like a floppy drive, and you need to distrust the data just as much as you distrust data on anything else. That's it. Thank you.